All right, we're back. We're on page 6 of note 16. We're talking about parametric equations. So we have a dx dt, which is left right, a dy dt, which is up down. We have a dy dx, which is just the slope of the tangent line or the slope of the curve. Function of t, though. Did I say dy dx? I hope so. Dy dx is a function of t. That's the thing we have to keep in mind. So if I want to find the second derivative, which is the same concept, it's concavity, as the original second derivative that you learned way back when. Concave up is concave up, concave down is concave down. No such thing as concave to the left, no such thing as concave to the right. So it's all about concave up, concave down. What we need to do is employ the chain rule because dy dx is actually a function of t. So we have to find the derivative of a function of t with respect to x. So we do the derivative with respect to x of dy dx is going to be the derivative of dy dx with respect to t, because t is the variable, then times dt dx. But instead of writing times dt dx, we divide by dx dt. Dx dt is the more natural thing to think about rather than dt dx. So let's see what we can do with that. So we're going to take the derivative dy dx with respect to t. So that's what we're doing. And then we're going to divide, I feel like this should be in a brighter color, divide by dx dt. It's not hard to do. It's a little tricky to remember, I guess, but it's just a chain rule. So you can always just think back, like, how would the chain rule make this happen? And then do it. So concave up, concave down, still the same idea. Let's see if we can find this. So I'm hoping something magical happens here. Maybe it does. I'm going to find dy dt. So I like to find that first because then I don't mess up the order of division as much. Dx dt. So we can combine these and say that dy dx is going to be 3. So we get 3 cosine of 3t over negative 3. I guess I should just read it. Negative 3 cosine 3t over 3 sine of 3t. This is not bad. I mean, I murdered that t, but this is just negative. Oh, that's not negative 1. It's negative 10. Cotangent. What am I doing? Long day. This is what happens when I record videos at the end of the day. Gotta get them done, though. Okay, so we get this. This, I believe, to be the derivative. And then I need the second. So this is dy dx. I feel like I should summarize that. Am I just stalling? I hope not. Negative cotan of 3t. All right, that's dy dx. What's part of our answer? All right, now what we want is the second derivative. So second derivative, we're going to do d dt of dy dx. And we're going to divide that by dx dt. Okay, so d dt of dy dx is going to be 3 cosecant squared of 3t. And then dx dt was 3 sine of 3t. There's like 3's everywhere, but they keep canceling. So here, I'm going to bring, so the 3's cancel. And then I'm going to bring the sine up, I guess, and make it cosecant cubed of 3t. Ooh, that's an announcement. There's going to be another one in 5 minutes because I forgot to turn off all my announcements. So that's great. I don't even know if it picks up that sound on the video. It probably doesn't, and I probably just make a big deal out of it. So let's see here. Cosecant cubed of 3t. I'm going to check it on the calculator and see how this went. All right, here we go. So switching over to a calculator somehow. Let's see. Calculator. So my calculator's on the wrong. I got another display because like stuff was going on. There's just too much. There's too many windows. So now I have a second display, but sometimes now my calculator's on one page, sometimes on another. Also, because I'm like actively teaching, sometimes I'm in degree mode now, and that's a tragedy. So Doc 7.2, go to radians, make sure your trig is working. So x of t is going to be, x of t is cosine of 3t, and y of t, y of t is going to be sine of 3t. So I want to do, Yeah, I want derivative of y of t with respect to t over derivative. If you're doing a lot of these problems, it's a good idea to actually store the derivative as a function of itself. So the calculator just hates writing it. Usually it hates writing tangent in its answer, but I don't know if I've ever seen cotan show up. Like, it's definitely defined, but I don't think it shows up as anything, as an answer. So that's our derivative. That's negative cotan of 3t, sure. And then what we want to do is the derivative of the answer with respect to t over the derivative of x of t with respect to t. And I'm going to press enter, and this should be the second derivative. So there, and again, it won't write cosecant, but that's negative cosecant of 3t cubed. Negative, though, what now? Why am I not getting a negative? I got negative there. The derivative of that would be negative. And then, oh, I just forgot. There was a negative on the, I did it to myself. And let me go back and show you. It's because when I wrote the first derivative, I put this negative sign in like a weird random spot. Then when I look back, I was like, oh, I can see that this is this. But if you go over, you'll see that negative right there. So this should have had a negative. So this should be negative, and our final thing should be negative. So it was actually negative. Okay, not bad though. I think what I'll do is maybe I'll split this page here. I'll come back in the next video and try to finish this page, and we'll see how it goes. So I will see you there.